what is alkane? An alkane is a hydrocarbon with only single bonds. And now, how to write the formula, or how to write the name of the molecule. So first of all, we need to know how we are going to write it. We're going to use the UPAC system. The UPAC system is a method of naming hydrocarbons. This method is approved by the International Unique Pure Applied Chemistry, or as you can see here, UPAC. Another thing that we need to know are the prefixes of the hydrocarbons. First of all, the alkane prefix is ane. So always when you're going to write an alkane, you got to put at the end ane. So we got ane at the alkane's prefix. Then we got meth, eth, prop, but, pent, ex, ect, oct, and nona. Each of them means the number of carbons that the hydrocarbon has. For example, we got meth. Meth has 1 carbon. Eth has 2. Prop 3. But 4. Pent 5. Ex 6. Ep 7. Octo 8. And nona 9. So when we got a formula of a molecule that has only single bonds and 1 carbon, this formula is called a methane. When we got 2 carbons, it's a ethane. When we got 3 carbons, it's a propane. 4 carbons, butane. 5 carbons, pentane, etc., etc., etc. But remember, only it is an alkane if it has single bonds. So now that we know this, we can answer some problems of how to name it. For example, we got these ones. There are 2 main steps to name a hydrocarbon, and in this case the alkanes. First of all, we need to identify the longest chain of carbons. In this case, it will be this. As we can see, here we got 1, 2, 3, 4 carbons. So by this, we can infer that this molecule is a butane. So we put butane. Before putting butane, we need to finally locate the alkyl groups. The alkyl groups are methyl, ethyl, propyl, butyl, etc., etc. So here we got 2 alkyl groups. First we got 1 methyl here on carbon number 2, and we got an ethyl on carbon number 3. So before starting to write the alkyl groups, we need to remember, always start naming molecules by the alphabet. So we first start with the ethyl. So we count 1, 2, 3. In carbon number 3, we got an ethyl. And then in 1, 2, in carbon number 2, we got a methyl. So this formula, it will be called 3-ethyl 2-methyl butane. So we can continue. Here we got 2 other formulas. This one is the name of an alkane already, and we need to find its molecule. And this is a molecule, and we need to find a name. So we need to start with this one. This is a 3-ethyl 4-methyl cyclobutane. When we're talking about cyclos, there are some geometric figures that we need to put in order to sign the carbons. For example, in this case we got a butane. So the geometric figure for butane is a square, as it has 4 sides. And we got 1 carbon here, 1 carbon here, 1 carbon here, and 1 here. So then we put the other things. For example, the alkyl groups. We got 3 on ethyl, so we count 1, 2, 3. Sorry. And then we put a key. Then we put here the ethyl, so it will be CH3, CH2. Then we go to the other. We got 4-methyl. So 1, 2, 3, 4. Here we put the methyl group. Then to name the molecule, we need we need to count out again, as we do it in the first exercise, the number of carbons. Here we have 1, 2, 3, 4. Remember, when we get a branch, for example this one, that is an alkyl methyl group, we can count by it, like the snake game on the Nokias. Here we got 1, 2, 3, 4. 1, 2, 3, 4, no matter the order. So, what we need to remember, always don't have 1, 2, 3, and then return 4, 5. No, only is following the snake. 1, 2, 3, 4, 1, 2, 3, 4, etc., etc. So here we got 4 carbons. What we can infer by this, that we are going to use the prefix "but", and as it has only single bonds, it's an alkane. So we got 2 alkyl groups, and there are methyls. So we put 1, 2, 2, comma. This is very important. We need to add a comma before putting the other alkyl group. 4, as it is the location of the alkyl group, hyphen, methyl. Then another hyphen, and then now we can put butane. Then we got these other 2 examples. The first one it says 1-ethyl trimethyl pentane. So we start drawing our formula. We got 5 carbons. How do we know this? Well, we know it because here we got a pentane. Pent means 5 in the prefix. So we put 1, 2, 3, 4, 5. Then we put the alkyl groups. So we got 1, in the number 1 we got an ethyl. CH3, CH2. In number 3 we have the methyl. 1, 2, 3. So here we put the methyl group. And now we're going down to this formula that is a little more complicated. So we counted first. What we need to do, we need to identify the longest chain of carbons. So we start 1, 2, 3, 4, 5, 6, 7, 8. Okay, now down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here we got the longest chain of carbon, as we can see. So we circle it to don't have to battle with other problem. And this is our change of carbons that says to us that this is a nonane. Why? Because it has 9 carbons, and the prefix of nona is for 9 carbons. So we then we start counting the alkyl groups. We got 1, 2, 3 methyl, 3, then 4, 5, 6. Methyls 2, sorry for the mistake. So I put 3, 6, and then methyl nonane. And that's how you make the names of alkanes and how do you form the molecules. Thanks for watching, I hope you like it.
Hi, in this tutorial I will talk about alkenes. What are alkenes? Alkenes are a double-bonded chain composed by carbon and hydrogen, sometimes composed by other elements. In this tutorial I will teach you how to name alkenes and how to structure them with their name. There are the prefixes and suffixes. The prefixes is for the beginning of the word equation. The first is met, et, prop, but, pent, ex, et, oct, non, dec. And for the suffixes, for single bond alkanes are ane, for double bond of alkanes is in, for triple bonds of alkynes is ein. And as you can see, the only difference is a letter. This one, this, and this is the difference between the single, double, and triple bonds. Final example. Yes. Okay. Now I will choose, I don't know, like the K, Kim, C. No, Nim. Better. It's easier to pronounce it. So now I will use the normal form to put the structure. So I put 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now I will put, I don't know, the branch in here, and I will put another branch in, I don't know, here. Yes? Okay? Do you see both branches? And I will put a final here methyl. Here methyl. Oh, sorry, I put the name. So CH3. I will put another here, CH3, and I will put here another H2 hyphen H2. It was 3. Okay, 3. So now, how many carbons I said it was? There were 9, so 9. Okay, so I will use the last way to put the name. So I will put non in the name. Okay. Now, where are the branches? Our is the closest double bond to the end. Here, no. Here, yes. So count 1, 2. Okay, in the number 2. So we put like 1, 2, 3, 4, 5. Okay, this is 6. But okay, 7, 8, and 9. Okay, where is our double bond? In 3 and 6. So we put 3,6 hyphen non. Okay, we have already our double bonds. So now we have to concentrate in our branches. Okay? Yes. So where are our branches? Oh, in number 6 and number 9. Yes, but we have 2 branches here. What we have to do? Okay, so we search for that branch. Oh, it's in number 6. Okay, we put 6. Well, I will put it above, so it won't. Okay, 6 hyphen. No, sorry. Comma 6. Why? Because there are 2 methyls. And because there are 2, the prefix of these ones will be B. If it was like 3 another in here, it will be 3 methyl, but there are only 2. So we put 6, 6 hyphen D methyl. Okay, dimethyl. Yeah. Now we will go with the ethyl. Yay! So now we search where's the ethyl. Okay, in number 9, the last one. So in another space we put 9 hyphen ethyl. Again, these 2 is with alphabetical order, blah, 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 blah. And that, okay? Is to large the names of, okay, you know, which is the ABCD, okay? So we will sing the song to know which is first, D or E. So A, B, C, D, okay, D wants. D wants a cup, yes, a cup, a cup, a cup, a cup, a cup, a cup, a cup. It's a winner. So we put 6,6 hyphen dimethyl hyphen 3,6 hyphen nonene. Okay, I will put more like here. The name, so you can see it better. Then is the field, the last one. Oh well, sorry. I'm sorry. Again, here is a field. Here is the field. I'm sorry because D is first, so we put 6,6 D methyl hyphen 9 hyphen ethyl hyphen 3,6 hyphen nonene, and this is our lab. Now the final example. It says 1 plural. Well, 1 it isn't necessary to name it, but in this case we will name it. Okay, for having order. So we have 1 plural, 5 ethyl. Wait, a hyphen. 5 ethyl, hyphen 3, hyphen methyl, hyphen 2, hyphen octene. Okay, so we have to search for the last expression, which is oct. So we put 1, 2, 3, 4, 5, 6, 7, 7, 8. Now we're going to concentrate in this one, okay? So, where is plural? In number 1. Oh well, first, 2 octene. 1, 2. I will put it here. So here's 1, 2, 3, 4, 5, 6, 7, 8. Make sure your numbers are enough visible. Now, 1 plural, 1 branch, and chlorine. Yes. Then 5 ethyl. Where is 5? Here. Branch, H2, H3. And then 3 methyl. H3, CH3. And this is our final structure in an alkene. As you see, it is more easier than naming it because it's more. It takes a lot of more time name it than drawing it. Okay? Thanks, you learned.
I'm going to talk about alkynes. Alkynes is an hydrocarbon that contains at least one triple bond inside of the main chain. So the first step for naming an alkyne is name the longest carbon chain. As you can see here, it contains different hydrocarbon compounds. So what you need to do is circle the first one to name it. It's circle the longest chain. As we don't have any alkyl groups, we just circle this. So this is basically the longest chain. So the second step, number carbons from the nearest triple bond. As we said, alkynes are the ones who contains at least one triple bond. So we can start like to the nearest. So if we count like this side from left to right, it's 1, 2, 3, and here in the third we have the triple bond. So let's count from the other side. Counting to right to left, we have 1, 2, 3. So it's the same if we start like from left to right. same as right to left. So let's start from the side. This is the first, second, third, fourth, fifth, and sixth. So for the third step, name each substituent. As we can see here, we have 1, 2, 3, 4, 5, 6. We need to use some prefixes, and for this example, it's 6, so the prefix is X, and the determination I, it's because alkynes. So you probably be wondering about the 3. Why the 3 here? Well, it's basically because we have the triple bond on the third carbon. So this is another example. The first step is circle the longest chain. So we can as well as do this and circle all around this, but this is not the case because this is not the longest chain. So here the longest chain is this one. So the second step, we need to enumerate every single carbon compound that we have here. So in this one we have 1, 2, 3, 4, 5, 6, and one alkyl group here. This is a group 9. So we need to start counting since the nearest bond, in this case, is an alkyne, so we need to find the triple bond. So it really doesn't matter at the first sight. It doesn't matter like if we start counting from left to right or right to left. But if you see here, we have in the left side we have more nearest the bromine. So we should start counting from the left side. So this is the first, second, third, fourth, 5, and 6. So let's name it. As we said here, we contain a alkyl group in the second carbon. So we put it the number of the compound that's here. It's 2, then a hyphen, bromo, because as you can see here, it's a bromine. Then another hyphen, and a 3, because in the number 3 we have the triple bond. And the prefix again, it's X, because we have 6 in total, and I, because we are talking about an alkyne. So we got another example here. The first step is naming the longest chain. In this example, we can do like this, circle all this chain, or we can do this. In this example, we use this arrangement. So let's name it. As you can see here, we have a 3-methyl, and this is because we got a alkyl group in the third, because we start counting like from the nearest compound since the triple bond. So it's first, second, third, fourth. So in the third one, we got an alkyl group. So it's 3-methyl. It's met because it's only one alkyl group, and butane because we have 4. What happens if we have a compound with its name right here, and we need to construct the structure of the alkyne? Well, it's simple. As you can see here, we have a but and ein. The ein stands for an alkyne, and but is the prefix that means that we have 4 compounds. So it will be like this. Another hint is that you have the number 2 here. So it means that we have the triple bond on this second compound. So it can be like this. As you can see here, it doesn't matter if we start counting to left to right or right to left, because we have the triple bond here in second. 1, 2, 1, 2. It's the same. So when we have the same conditions in the same sides, we should usually start from left to right. So let's start here. 1, 2, 3, 4. This is the longest chain, and we don't have another alkyl group like here or here. So it's just a 2-butyne. Then after we put it like this, we just follow this and put the triple one here. And it's really simple because you're talking about an alkyne, so it's a triple bond. It's 3 hyphens, as you can see here. And that's pretty much what you need to do. In the second example, we have propyne. Prop, it's the suffix that stands for 3, while ine, because we are talking from alkynes, that mean we can at least have a triple bond inside it. So let's start doing the structure. So we have 3 carbons here, and because we have the prop, which means 3, so we have here 1, 2, 3. So the second step to do a structure, it's to put the bond. So in this case, I think I'll put it in here, and in here it's only a hyphen. This is like in Iseo or the first step. This will not be the complete one because we're just initializing with the structure. So since we have to the nearest bond to the right, we will start counting from this side. It's 1, 2, 3. So the last step is once we shared about we don't have any alkyl group like here or here, we just put the hydrogens where it needs to go. For example, the hydrogens need to put when we don't have like four units in each carbon. So as you can see here, we only have 1, so it will be H3, as you can see here. And in this carbon, we don't need to put anything because we have 3 here and 1 here, and the sum is 4. So we only put a CH here, which means it 1 because we only have 3 here, and with this H is another, so it means 4. And for the last, we circle our longest chain, and this is the end of this problem. So for the last example of the apartment of alkynes, so here let's remember the steps. The steps is for naming. Check first this part. It means butyne, which means but, 4, and Y, it's a termination for alkynes. So alkynes means that we have at least 1 triple bond inside of the entire chain. So let's start counting the carbons we have. It says we have 4, so I put 1, 2, 3, 4, and this is an alkyl group. This one in here is an alkyl. I'll put it in here, alkyl. It's an alkyl group. It's a derivation of 1 chain. So the derivations that are the alkyls will be in the second here, in the second part of the entire name. Methyl. Why methyl? Methyl is when we have only 1 alkyl group. For example, if we only have 1, it's methyl. If we only have 2, it's ethyl, and so on. It depends on the how many alkyl groups we have. So the suffix will change. And the number 3, it stands for in which carbon of the longest chain it will be. For example, if we start going to the nearest, it will be from left to right because we have like more nearest to this side. So it is 1, 2, 3, 4. So this is the longest chain. This one. Imagine a circle here, because otherwise if we do 1, 2, 3, 4, it will be the same, a longest chain. But I'll use this example. Go in a straight line right here. So the number 1, this one, stands for in which compound we have the triple bond. So it's here. That's why we have 1 hyphen butane, because we have 4, and it's an alkyl. And methyl, because we only have 1 group here, and it's located in the number number 3.